hoping that I didn't waste too much time going over your test. You will need graph paper. Keep your calculator handy for this. We are starting, and I'm just going to add this. We are going to solve systems graphically today. And any system you can solve on your calculator also, using your graphing utility, which is what we'll also go over today. So, let's say I have the system y equals x minus 2 and y equals negative 2x plus 7. When I solve a system, what I'm looking for is where the graphs intersect. Okay, that's what I want. And that point is the answer. Now, we did this last year in algebra class, or 2 years ago in algebra class. This year, we're going to do it in more than 2 variables, though. So you're going to have a lot more than this. It's going to start relatively easy, but then it's going to turn into like hang me now. Which is why you're going to want to have your calculators handy each day, so that I can show you the tricks to make your life a little bit less horrible. All right, so this is our system. And we are going to graph both of those. So I'm going to switch over to here. So x minus 2. My y-intercept is negative 2. And my slope is up 1, right 1. And I'm going to want to extend that line as far as I can, because I don't know where the answer is going to be. So that's that first graph. That's this one. So I just graphed that one. Okay, the next one, my y-intercept is 7, and my slope is down 2, right 1. So 1, 2, 3, 4, 5, 6, 7. Wow, right at the top of my graph, and I go down 2, right 1. And you'll notice that those two graphs meet at a point. They meet at this point. Now, they are not always going to meet exactly, but in this case they do. They meet at the point 3, 1. So that's the solution for my system, and my system was this. That was my system. So what does this mean? This means if I substitute x equals 3 and y equals 1 into both equations, it solves both, or both are true. Now, if I substitute it in and one of them doesn't come out correctly, then I have made a mistake somewhere. Which one? It solves both, as in both are true. so continuing on in here. A solution to a system, I'm just putting what I just had on the other slide over here. So if you already wrote it, you don't need to write it again. A solution to a system makes all equations of that system true. Okay, not just one of them. So, example. Here's my system. I'm going to give you another one. 3x plus y equals 5, and x minus y equals 7. And I ask, is 1, 2 a solution? If this is, then both or all equations will be true. You get what I'm saying? So how am I going to check that? Well, I'm going to put this in for x and y in both of these and check them. Now, just because it works in one does not mean that therefore it's correct. It has to work in both of them. So I'm going to copy this, hopefully all of it this time. Nope. My copy there is not doing what I want. Copy. There we go. Just added it. Oh, well, paste. Okay. Hopefully this will move that. I don't know. Beggars can't be choosers. All right, here we go. So we're going to put that in. So we have 3 times, so I'm going to put in x is 1, 3 times 1, plus 2, there's my y, equals 5. And I get 3 plus 2 equals 5, and 5 equals 5. That one worked. So I need to check the other one. I need to check both. Check both. So the next one I have 1 minus 2, does that equal 7? Well, 1 minus 2 is negative 1. That does not equal 7, so no, it does not. See, this worked for the first one, but it does not work for the second one. So therefore, I conclude not a solution. Does that make sense? As I graph these, we have a few possibilities. Possibility 1, they intersect. If they intersect, I have a system that is independent, meaning I have different lines, and consistent, meaning I have an answer. And it'll generally look something like this. Or something like this, you know. The point being, they intersect. The lines intersect, and I get, see, this is my answer. That's possibility 1. Possibility 2, they are parallel. Well, that means they don't intersect. I guess it's just going to get worse, right, as they build the building. All right, so if they're parallel, they are independent because we do have different lines. But the system is inconsistent because there's no solution. Because they never meet. And the parallel lines are going to look something like this. Now, if at any point you're solving this and you notice parallel lines have the same slope, right? So if at any point you get the same slope, you know that you're not going to have the solution pretty much. If you have the same slope but different y-intercepts. So we're actually going to practice a couple of those where we're just going to determine what our situation is. All right, so our third and final, and I will back up to that, but our third and final possibility is that they are basically the same line. And if that happens, we call that a dependent system. And whether it's consistent or not, we could debate. But meaning the end here is we have infinite answers. So here's my directions for these three examples. Determine if the system is dependent or independent, or consistent, inconsistent, if there's a solution, find it. So dependent, independent. Dependent means they're the same line. Independent means they're different lines. Consistent means there's answers. Inconsistent means no answer. So to rehash our possibilities, this, where they intersect, that's a consistent and independent system. If I have parallel lines, that's an inconsistent system, and they are independent. And if they're the same line, meaning I just graph them and they're on top of each other, that is well, it's debatable whether it's consistent or not, but they are dependent because they're the same line. All right, so in these two cases, they're parallel lines, they have the same slope. This one not only has the same slope, but it also has the same y-intercept. So it's exactly the same. All right, so I'm going to put three examples up, and let's see if we can figure them out.
Can you go back to the other one?
Yes. Going back. Let's wrap that up. I'm hoping I don't have to go through the procedure of graphing these so much, because we just got through a chapter on graphing lines and things. And you can also, I wanted to get to your calculator. Perhaps when the bell rings and we have that couple of minutes, we'll go to the calculators to see how we can do it on our calculator without graph paper. All right, so let me erase all this. I don't know how my thing gets all jumbled up. All right, so this is going to be example 1. We're going to follow those directions I just had up there. All right, so in any case, if I'm trying to solve this, I'm going to solve for y if I'm doing it graphically. All right, so this one I solve for y. What do I do? Okay, so I'll subtract 7x. And I have negative y, so I multiply by -1. This one, how do I solve that one? So that one's ready to graph. How about the next one? What do we do to both sides to solve for y? We add 7x, right? So I get 7x minus 6. Now what do I notice about these? They're the same. Therefore I conclude this is a dependent system and there are infinite answers. And I'm done. No reason to graph that. Alright, let's do the next one. Example 2. So there's my system. And what do I have to do? Okay, on the first one I'll have to clear the fraction. Okay, so I'll multiply both sides by what? So I get 3x minus y equals 3. Now what?
Subtract the x.
Subtract the 3x. And then? Multiply by negative 1. Alright, so that one's ready to graph. You see how I'm indicating, okay, I'm ready to do something with that. Alright, this one, I need to solve for y. What do I do? Huh? So I add 3x. I'm going to get 3x plus 4. Alright, now without graphing, what do I notice about these? Same slope, but they do have different y-intercepts, so they are parallel. So I'm going to say this is an independent system, but it's inconsistent because there's no answers. So no solution. Do you get how we saw that without even graphing it? And one more. One more example. Well, we got all the examples, the other two, right? The confusing ones. So this one is already solved for y. That's a minus 1. So there are different slopes. So right away, I know that I can say that this is a consistent and independent system. So I have a solution. So we graph this line, negative 1, and with a slope of 2. So I'll have to clear this out. So slope of 2 means up 2, right 1. And I want to get enough points here that, because I don't know where this answer is going to be. I want to draw it really neatly. Okay, that's the first line, and the other line was at 5 and down 2, right 1. 1, 2, 3, 4, 5, down 2, right 1. And this is a good example of one that doesn't always hit really nice. It looks like it hits right here. And going this direction is pretty hard on this little gizmo. Alright, so this is my answer. And it looks like that's 1.5, comma 2. So you could say 1.5, comma 2. Okay, I'm going to put 2 examples up, and I want you to have your calculators out and ready so that we can solve these 2 examples. On your graphing utility, yes. All right. Huh? I graphed both of these.
I just need to.
All right, so our system is going to be y equals negative x plus 3, and y equals 3/2 x minus 2. And we're going to use our graphing utility to find the answer. So as we get to graph mode, we're going to want to make sure that we have the right, we want to start at standard view window. So if you're looking at it, it's like, gosh, this doesn't look right, or it looks funky, check your view window. Make sure you have the standard view window of an x min of negative 10, a max of 10, a y min of negative 10, and a y max of 10. That's your standard view window. Now on the Casio, you can just hit standard, and it'll switch it right there, right fast, and you don't have to type those in individually. All right, so in y1, now we do have to solve for y. In this case, it's already done, so I'll put in negative x plus 3, no problem. And in y2, this is also solved for x. Now, unless you have the prism, you can't put that fraction in too nicely, so you have to do parentheses 3, do this little thing, 2, and then you have an x minus 2. So you put those both in. Now we could graph this by hand and get the answer, no problem. So I want you to go ahead, graph it, put those in, graph it, and then on the Casio, what you're going to do is you're going to do gsolve from the top, and you're going to find intersect.
ICT.
Probably. And then it should pop out the answer. Now, on a TI, if you're a poor TI person, you do not have this. You do have the intersect option, but it's going to ask you for, I think, a left bound, a right bound, and a guess. So you have 3 extra steps. And if you are someone who listens to me, then you have just 2 steps, gsolve, intersect, and it gets it to you. So, gsolve, intersect, what do you get?
X2, Y1.
X2, Y1. Done. Easy. You can check all your answers. Listen, there's no reason to get any of these wrong, because you can check your work really quick on your calculator. All right, let's do the next example.
Wait, where is the gsolve?
Gsolve is...
To try to enter in.
Okay, so put in your 3/2, and then you have x. I want to get while you type that in, I'll get the next example up there. So we have y. Now this one we're going to have to do a few extra things to before we put it into our calculator. Oops.
Oh, I see it. Never mind.
Is this the one I want? This is probably not the one I want, but whatever. Okay, so that's going to be the next one. Did you find it?
Yeah.
2, 1. Okay, so x, 2. All right, so I can't put this system into my calculator directly. What do I need to do first? I do need to solve for y. So I subtract x on this one, and I get y equals negative x plus 2. On this one, I have even more steps. What do I need to do first? Subtract 2x. So I get 4y equals negative 2x plus 12, and then I divide by 4, and I get negative 1/2 x plus 3. So I'll put in y equals negative 1, this little thing, 2x plus 3. So I'll put those 2 in, and I do the same thing. I do my gsolve, and it'll pop out the answer. All right, and that's pretty much everything for today, so I'm going to stop the recording. Did the bell already ring?
Yeah.
No? Got a couple minutes?
It says that